Let's take a look at this example. Please notice that this time we have in the circuit dependent voltage source, okay? But don't scare of it and just simply perform all procedures like we did before, okay? So what we're supposed to do first, we have to find, okay, our mesh currents, okay, loop currents. So if this is my I1 and this is my I2. Okay, now we're supposed to simply find the sum of the impedances in loop 1. So I have Z11 is equal R1 plus R2, which is equal 600 ohms plus 400 ohms is equal 1 kilo. Okay, so this is my Z11. Next I have to find Z12, which is equal to Z21. Okay, so this is the impedance between loop 1 and loop 2. Please notice that we do not have any component beside the voltage source between these two loops. That's why our impedance is equal 0 ohms. Next I'm supposed to find Z22. Z22 is the sum of the impedances in loop 2. So I have resistor R3 and capacitor. So I have R3 plus Z of C. Okay, so R3 is equal to 2 kilo ohms plus 4 kilo ohms and angle of negative 90 degrees, because capacitor, okay, if it comes to the impedance, goes always with angle negative 90 degrees or negative J. So if Z22 is equal, so I have 2 exponent 3 plus 4 exponent 3 and angle of 90 negative. This is equal 4.47 kilo ohms and angle of negative 63.43 degrees. Okay, so this is my Z22. Next I'm supposed to find the sum of the voltages in loop 1. Okay, so I have sum of the voltages in loop 1. Okay, please notice that we have dependent voltage source, okay, and the positive sign is at the top. So theoretically this voltage source will push the current up. So if the voltage source is going to push the current up, the direction of the current of the voltage source is going to be the same like the direction of current I1. That's why I'm going to say this is positive. So this is 6 times VR3. Okay, so this is my dependent voltage source, and because the current pushed by the voltage source is going to go up and is going to oppose my I1, that's why I'm going to write over here negative Vs. Okay, so this is equal 6 times, and VR3 is nothing else, just IR3 times R3. But because current I2 goes through resistor R3, okay, I'm going to write that this is I2 times R3. Why I have to rewrite VR3 as the product of the current and resistor? Because in the mesh equations we are going to use the currents, okay, and then I need the current, not voltage. That's why you're supposed to rewrite VR3 as the product of the current and resistance. Let me remind you, because current I2 will go through the resistor R3, I wrote this as a product I2 times R3 minus Vs, which is equal 10 volts. Okay, so next I can find the sum of the voltages in loop 2. Sum of the voltages in loop 2 is nothing else, just one voltage source, okay, because in this loop we have just this voltage source, and this voltage source is going to push the current up, and the direction of this current will match to the direction of I2. That's why this is going to be positive, so I have Vs, and this is equal 10 volts. Next, I'm supposed to write the formula for the circuit, okay, with two loops. So I have Z11, I1, okay, and I have minus Z12, I2 is equal sum of the voltages in loop 1. And I have negative Z21, I1 plus Z22, I2 is equal sum of the voltages in loop 2. Okay, so this is the general formula for the mesh equations, okay, for circuit which has two loops. So let's substitute the variables by the numbers. So if Z11 we found is equal 1 kilo ohm, we have Z12 over here, we have Z22, and we have some of the voltages, so let's plug them into the formula. So Z11 is equal 1 kilo ohm, and I have I1 minus Z12 is equal 0, so I'm going to have 0 ohms, I2, so this is equal 6 times I2 R3. I forgot over here to write, instead of R3, 2 kilo ohms, okay, so I have like 6 times R3, which is equal 2 kilo ohms, is going to be equal 12 kilo ohms. So I'm supposed to write this as 12 kilo ohms, I2 minus 10 volts. Okay, so I have to write this over here. So this is 12 kilo ohms, I2 minus 10 volts. So now you can see why we need to convert the voltage which we had over here to the product of the current and resistance, because we need the current. Okay, we need the current because we are going to move this term to the left side, and we are going to combine with the term which contains I2. So now let's do second mesh equation. So I have negative Z21, we said this is equal 0 ohms, and I have I1 plus Z22, we have 4.47 kilo ohms, and angle of negative 63.43 degrees, and this is my I2, and this is equal 10 volts. Okay, so next we're supposed to combine the like terms. I'm going to move this to the left side. So I have 1 kilo ohm, I1, and I'm going to have minus 12 kilo ohms, I2, okay, and this is equal minus 10 volts. Over here I'm going to have minus, I have to copy down the second equation, second mesh equation, ohms, and I have I1 plus 4.47 kilo ohms, angle of negative 63.43 degrees, I2 is equal 10 volts. Okay, so now we can find the delta. Okay, so delta is equal, I have 1 kilo ohm and I have minus 12 kilo ohms and I have 0 and I have 4.47 kilo ohms and angle of minus 63.43 degrees. Okay, so this is equal. Now we're supposed to multiply 1 kilo ohm times 4.47 kilo ohms and minus the product of these two numbers, but anything multiplied by 0 will give me 0. That's why I'm not going to even consider this operation. Simply I'm going to multiply 1 kilo by 4.47 K angle. Okay, so I have this is 4.47 mega ohm square and angle of negative 63.43 degrees. Okay, so this is my delta. Next, I'm supposed to find I1. This is the number which will help me to find current I1. Okay, so I have to substitute the first column of my delta by the voltages. Okay, so I have minus 10 volts and I have 10 volts and I have to copy down the second column of my delta. So I have minus 12 kilo ohms and I have 4.47 kilo ohms and angle of minus 63.43 degrees. This is equal. I'm going to use the calculator. I'm going to multiply this number by this minus this times that. So I have 10 negative times 4.47 exponent 3 and angle of 63.43 negative minus 12 negative exponent 3 times 10 equals 107.7. Okay, so I have 107.7 kilo volt ohm. Okay, and angle of 21.79 degrees. Okay, so this is my NI1. Next, we're supposed to find NI2. This is equal. We have to copy down the first column of delta, so I have 1 kilo ohm and angle 0. And the second column we're supposed to replace by the voltages. So I have minus 10 volts and I have 10 volts. So this is equal. 1 kilo times 10, this is equal 10 kilo volt ohm. Okay, so I'm not going to even consider the multiplication of these two numbers because 0 times anything will give me 0. So this is my NI2. Now we can find the current I1. I1 is equal NI1 over delta, where NI1 is equal 107.7 kilovolt ohm and angle of 21.79 degrees divided by delta, which is equal 4.47 mega ohm square and angle of minus 63.43 degrees. Okay, so this is equal 107.7 exponent 3 and I have angle of 21.79 divided by 4.47 exponent 6, and angle of 63.43 negative. This is equal 24.09 milliamps and angle of 85.22 degrees. Okay, so this is my current I1. Next, I supposed to find I2. Okay, so someone is going to say we can also cancel out ohm with the square, so volt over ohm is equal amp. Okay, so everything, whatever we do so far is correct. So I2 is equal N I2 over delta. So we found that Ni2 is equal 10 kilovolt ohm divided by delta, which is equal 4.47 mega ohm square. Okay, so again ohm and square will cancel out, and I have angle minus 63.43 degrees. This is equal 10 exponent 3 divided by 4.47 exponent 6, and angle of 63.43 negative equals 2.23 milliamps and angle of 63.43 degrees. Okay, so this is my loop current or mesh current I2. Next, we're supposed to find IS, okay, current which will go through this branch. So far we found I1 and we found I2. So in order to find IS, you're supposed to realize that IS is the combination of current I1 and I2, where I1 will go through this branch from the top and I2 will go through this branch from the bottom. So they're going to oppose each other. That's why in order to find the value of IS, you're supposed to subtract them. So I'm going to write that IS is equal I1 minus I2. I1 is equal 24.09 milliamps and angle of 85.22 degrees minus 2.23 milliamps and angle of 63.43 degrees. Okay, so this is equal, we have 24.09 exponent 3 negative, and I have angle of 85.22 minus 2.23 exponent 3 negative and angle of 63.43. This is equal 22.03. This is 22.03 milliamps and angle of 87.37 degrees. 87.37 degrees. Okay, so this is my current IS. Next, I'm supposed to find the voltage VR1. VR1 is the voltage across resistor R1. Okay, please keep in mind that I1 is the current which goes through the resistor R1. So current I1 times R1 will give me voltage across resistor R1. And also I'm supposed to find VC, voltage across the capacitor. Voltage across the capacitor is going to be found by multiplying I2, because I2 goes through this capacitor times the impedance of this capacitor, okay? So let's do it. So I have VR1 is equal I1 times R1, where I1 we found is equal 24.09 milliamps and angle of 85.22 degrees. Okay, this is my current over here, times R1, which is equal 600 ohms. So this is equal 24.09 exponent 3 negative angle of 85.22 times 600. This is equal 14.45 volts and angle of 85.22 degrees. Okay, so this is VR1. If I want to find VC1 or VC is equal I2 times Z of C, where I2 we found is equal 2.23 milliamps. I have 2.23 milliamps and angle of 63.43 degrees times 4 kilo ohms and angle of negative 90 degrees. So this is equal 2.23 exponent 3 negative and angle of 63.43, okay, times 4 exponent 3 and angle of 90 negative. This is equal 8.92 volts and angle of negative 26.57 degrees. Okay, so this is my voltage across the capacitor. Next we're supposed to find the power at resistor R2. Okay, so I have PR2 is equal the current, okay, square times the resistance. But please keep in mind that we are dealing with the peak voltage. So if you want to find the power at resistor R2, you have to simply multiply 1/2 by the square of current I1 times R2, because this is peak voltage. So we talk about the peak current 2. So this is 1/2 times I1 to the second power times R2. So this is equal 1/2 times I1, and I1 was equal 24.09 milliamps to the second power times R2, 400 ohms. So we are going to use the calculator. We have 0.5 times 24.09 exponent 3 negative square times 400. This is equal 116.06 milliwatts, and this is the power at resistor R2. Next, we're supposed to find the reactive power QC. QC, okay, is equal 1/2 I2, because current I2 goes through capacitor. Okay, I2 goes through the capacitor, that's why I'm going to use the capacitor. Current as the I2 raised to the second power times z sub c. This is equal 1/2 I2 is equal 2 point, this is my I2, 2.23 milliamps. So I have 2.23 milliamps raised to the second power times z sub c, which is equal 4 coulombs. This is equal 0.5 times 2.23 exponent 3 negative raised to the second power times 4 exponent 3. This is equal 9.94 millivolt amp reactive. And now we can say that the problem is solved.